Okay, students, we understood that solid, liquid and gas, all three states of matter expands on heating, and solid also expands on heating. But solid, this is an example of solid. I'm showing you a solid. This solid has length, isn't it, and area. So area, as well as it has some breadth, so you can find the volume of this solid, isn't it? Solid has length, area and volume. Okay, now we will understand the expansion of length of the solid, the expansion of area of the solid and the expansion of volume of the solid accordingly. Okay, one by one. First, we will understand coefficient of linear expansion of solid. Linear expansion means coefficient of increase in length. Let me read the definition first. It is defined as the fractional increase in length of the solid per degree Celsius rise in temperature. It is defined as the fractional increase in length of the solid per degree Celsius rise in temperature. Okay, what is fractional? Fractional means increased length divided by original length. Original length is the fractional increase. Okay, this is the fractional increase. Suppose this is a rod at 0 degrees Celsius and the length of the rod was x centimeter. Let us assume this rod at 0 degrees Celsius is x centimeter long. Now when you increase the temperature, the length of the rod is increased and the new length of the rod is x plus a centimeter. Okay, x plus a centimeter. When you increase the temperature to 1 degree Celsius, are you getting my point? When the temperature was 0 degrees Celsius, the length of the rod was x centimeter. When you increase the temperature 1 degree Celsius, the length of the new length of the rod is x plus a centimeter. So what is the increased length? Increased length is new length x plus a, new length minus old length or original length. Original length is x divided by original length. Got my point? Increased means new length minus, or suppose I have rupees 5. I have rupees 5 and somebody gave me rupees, I don't know how much, but now I have rupees 12. Now increase in money is how much? The new amount minus the old amount. That is 12 minus 5 is 7, isn't it? So new minus old. Okay, new length minus old length is the increased length divided by original length is what you call fractional increase. Fractional increase means increased length divided by original length. Now this plus x and minus x cancels out, a upon x. This is the fractional increase in this example. Let us understand this and deduce the relation. I hope you are following me. You are getting my point. Let me erase this. Okay, please remember the definition. It is defined as the fractional increase in length of the solid per degree Celsius rise in temperature. Please remember this definition. Take the screenshot. I'm erasing this and I'm going to deduce the coefficient of linear expansion of solid. Okay, let the length of a solid rod at theta 1 degree Celsius be L1. Okay, and at higher temperature theta 2 degrees Celsius is L2. I hope you got my point. Well, theta 2 degrees Celsius is greater than theta 1 degree Celsius. Theta 2 is higher temperature, theta 1 is lower temperature. When the temperature was theta 1 degree Celsius, the length of the rod was L1, and when you increase the temperature, this is greater than theta 1. When you increase the temperature to theta 2 degree Celsius, obviously the length of the rod will increase, isn't it? Because there takes a thermal expansion occurs. So when the temperature rises from theta 1 degree Celsius to theta 2 degree Celsius, the length increases to L2. Okay, new length is L2. Got my point? Okay. For theta 2 minus theta 1 degree Celsius, rise in temperature. I hope you are getting my point. Previously, the temperature was theta 1 degree Celsius. Now, the new temperature is theta 2 degree Celsius. Got my point? And theta 2 degree Celsius is higher temperature than theta 1 degree Celsius. So, rise in temperature is how much? How much temperature has increased? Theta 2 degree Celsius minus theta 1 degree Celsius, isn't it? Let me give you an example. Suppose the original temperature is 2 degrees Celsius. Later on, the temperature became 3 degrees Celsius. So the rise in temperature is how much? 3 minus 2 degrees Celsius, isn't it? Higher temperature minus lower temperature gives you the rise in temperature. Okay. For theta 2 minus theta 1 degree Celsius rise in temperature, increase in length equal to L2 minus L1, isn't it? Previously the length was L1, now the new length is L2. So L2 minus L1 gives the increased length, isn't it? Got my point? Okay. Then for 1 degree Celsius rise in temperature, rise in temperature increase in length equal to L2 minus L1 by theta 2 minus theta 1, isn't it? If 20 apples cost rupees 80, 1 apple cost rupees how much? 80 divided by this 20 comes down. This is unitary method. 4. If the cost of 20 apples is 80, the cost of 1 apple is 4. Got my point? Similarly, for theta 2 minus theta 1 degree Celsius rise in temperature, increase in length is L2 minus L1. So for 1 degree Celsius rise in temperature, increase in length is L2 minus L1 upon this theta 2 minus theta 1. This is unitary method, isn't it? We have learned this in junior classes. So fractional, now comes the word fractional. Fractional increase in length per degree Celsius rise in temperature. This is the definition of linear coefficient of solid, isn't it? Coefficient of linear expansion of solid. Fractional increase in length per degree Celsius rise in temperature is denoted by letter alpha. Okay, coefficient of linear expansion of solid is denoted by letter alpha. This is the definition. So fractional increase in length per degree Celsius rise in temperature is how much? L2 minus L1 divided by theta 2 minus theta 1 was already there. Now when you divide by L1, you get fractional increase. I have already told you, increased in length divided by original length is the fractional increase in length, isn't it? So the coefficient of linear expansion of solid is L2 minus L1 divided by L1 into theta 2 minus theta 1, where theta 2 and theta 1 are temperature. theta 2 is higher temperature and theta 1 is lower temperature. Okay, unit, let us write the unit of this first. Unit of coefficients, let me erase the upper part. Okay, let me do here first. Unit of coefficient of linear expansion of solid, SI unit and CGS unit. Okay, see here, length minus length is length, isn't it? Suppose this length, we write the unit centimeter. Okay, centimeter minus centimeter, we get centimeter, and this centimeter cancels out, isn't it? Let me make you understand this better. Suppose 10 centimeter minus 5 centimeter divided by 5 centimeter. New length is 10 centimeter. I am just giving an example. Okay, new length is 10 centimeter minus original length is 5 centimeter, and this original length is 5 centimeter. 10 centimeter minus 5 centimeter by 5 centimeter. 10 minus 5 is 5 centimeter, isn't it? Divided by 5 centimeter. So this centimeter and centimeter gets cancelled, 5 gets cancelled. So centimeter and centimeter gets cancelled means this length and this length, unit of this length in the numerator and the unit of length in this denominator gets cancelled. So only the unit of temperature remains, isn't it? So the SI unit is per degree Kelvin or per Kelvin, and CGS unit is per degree Celsius. Okay, I hope you got this. Now let us find the value of L2 from this equation. Alpha equal to L2 minus L1 by L1 into theta 2 minus theta 1. What will be the new length L2? This is the coefficient of linear expansion alpha. Since alpha equal to L2 minus L1 upon L1 into theta 2 minus theta 1. I hope you are getting me. Or let us cross multiply this. Okay, alpha into L1 theta 2 minus theta 1 equal to L2 minus L1, isn't it? And cross multiplying this denominator with alpha. Or alpha into L1 theta 2 minus theta 1 plus L1. This L1 comes to the left hand side, becomes plus minus L1, L2 in the right hand side. So therefore L2 equal to L1, and L1 is common. You can take L1 common. Within the bracket remains alpha theta 2 minus theta 1 plus 1, because alpha is, L1 is taken common outside. So the new length of the rod is L1 into coefficient of linear expansion of that solid into rise in temperature plus 1. Got it? Now we will move on to the next topic, coefficient of superficial expansion of solid. Okay, coefficient of expansion of area of solid, area. Coefficient of superficial expansion of solid means the coefficient of area, increase in area. It is defined as the fractional increase in surface area of solid per degree Celsius rise in temperature. This is the definition. Please take the screenshot of this. You can find this definition in your book as well. I am going to deduce the relation. Okay. Let A1 be the area of a solid at theta 1 degree Celsius and A2 be the area at higher temperature theta 2 degrees Celsius. Okay, when the temperature was theta 1 degree Celsius, the area of the solid was A1. Now when the temperature is increased to theta 2 degrees Celsius, which is greater than theta 1, which is higher than theta 1, when the temperature is increased to theta 2 degrees Celsius, the new area became A2. Okay, like this. This is just an example. Okay, previously the area was A1, this much, when the temperature was theta 1 degrees Celsius. When the temperature is increased to theta 2 degrees Celsius, the area also increased. Theta 2 degrees Celsius. When the temperature is increased to theta 2 degrees Celsius, now the new area is this much. Area also increased. Okay. Now let me deduce. Okay. For theta 2 minus theta 1 degree Celsius rise in temperature. I hope you are getting my point. For theta 2 minus theta 1 degree Celsius rise in temperature, increase in area equal to A2 minus A1, isn't it? New area minus original area is the increase in area. Temperature, new temperature minus original temperature is the increase in temperature. Okay, for 1 degree Celsius rise in temperature, increase in area equal to unitary method A2 minus A1 upon theta 2 minus theta 1, isn't it? This theta 2 minus theta 1 comes down here. Therefore, fractional increase in area. Now comes the definition. Okay, fractional increase in area of the solid for degree rise in temperature. For degree rise in temperature is beta. Okay, we denote the coefficient of superficial expansion by the letter beta. Okay, this is the definition of coefficient of superficial expansion. I had already written and you saw that. Fractional increase in area of the solid per degree rise in temperature beta equals to A2 minus A1 is the increased area divided by original area is the fractional increase in area into theta 2 minus theta 1. Okay, this is the coefficient of superficial expansion unit. See here, area, unit of area comes here and unit of area is in the denominator as well. So unit of area from the denominator and the unit of area from the numerator gets cancelled. So only the unit of temperature, that is theta, remains. Okay, so the SI unit will be per Kelvin and CGS unit will be per degree Celsius. Got my point? Now let us find the new length A2, new area A2, new area of the solid. Let me erase this. Please take the screenshot of this. Okay, we will move on to find the increased area A2. Okay, from this expression, coefficient of superficial expansion, we have since beta equals to A2 minus A1 upon A1 into theta 2 minus theta 1, isn't it? So let us cross multiply. Beta into A1 theta 2 minus theta 1 equal to A2 minus A1, isn't it? We cross multiplied this denominator with beta, or beta A1 theta 2 minus theta 1. When you take this minus A1 to the left hand side, becomes plus A1 equal to A2. Okay? Or A1, we take common A1. Beta remains within the bracket, and theta 2 minus theta 1 plus A1 is outside, so 1 remains within the bracket equal to A2. So new area of that solid is A1 into beta. Beta is the coefficient of linear expansion of coefficient of superficial expansion of the solid. Okay, it has value which I gave in the table before starting this thing. You have seen that iron has 1.2 into 10 to the power minus 5 per degree Celsius, isn't it? Okay, this is the new area of the solid when temperature rises from theta 1 degree Celsius to theta 2 degree Celsius. Okay, A1 is the original area into beta is the coefficient of superficial expansion of the solid, and this is the rise in temperature plus 1. Got this? I hope you understood. Now let's move on to the next topic, that is coefficient of cubical expansion or the volume expansion. Okay, let me continue this. Coefficient of volume expansion. Since we deduced or we understood the superficial expansion of solid and the linear expansion of solid, the coefficient of linear expansion of solid and the coefficient of superficial expansion of solid. Now we will move on to the next topic, coefficient of volume expansion of solid, or this can be said as coefficient of cubical expansion of solid. Okay, it is defined as the fractional increase in volume of the solid per degree rise in temperature. Please note this definition. I'll erase this. Okay, this is very, very simple. I'll make you understand. Suppose let the volume of a solid be V1 at theta 1 degree Celsius and V2 at higher temperature theta 2 degrees Celsius. Okay, let the volume solid be V1 at theta 1 degree Celsius and V2 at higher temperature theta 2 degrees Celsius. When the temperature was theta 1 degree Celsius, the volume of the solid is V1, and when the temperature is increased to theta 2 degree Celsius, volume of the solid expands and the new volume is V2. Okay, so rise in temperature is what? Theta 2 minus theta 1. For theta 2 minus theta 1 degree Celsius, rise in temperature, increase in volume will be equal to V2 minus V1. New volume minus original volume will be the increase in volume. So new temperature minus original temperature will be the rise in temperature, isn't it? Increase in temperature. Unitary method now. For 1 degree Celsius rise in temperature, increase in volume will be V2 minus V1 divided by this theta 2 minus theta 1, just unitary method. Therefore fractional, this is the definition from the coefficient of cubical expansion, okay, of solid. Fractional increase in volume of the solid per degree rise in temperature is denoted by the letter gamma. Okay, coefficient of volume expansion of solid is denoted by the letter gamma. This is the definition of coefficient of volume expansion of solid. Fractional increase in volume of the solid per degree rise in temperature is, fractional increase means V2 minus V1 increased volume divided by original volume, isn't it? Theta 2 minus theta 1 per degree rise in temperature. So this is the coefficient of volume expansion of solid. Okay, now let us write the unit of coefficient of volume expansion. Unit is SI unit is in the numerator the unit of volume comes, and in the denominator also the unit of volume comes. So the unit of volume and the unit of volume gets cancelled, only the unit of temperature remains. So SI unit is per Kelvin and CGS unit is per degree Celsius. Okay, I hope you got this. Now let us find the increased volume, that is V2. Let me erase this. Please take the screenshot. We have gamma equal to V2 minus V1 divided by V1 into theta 2 minus theta 1, isn't it? From the definition of coefficient of cubical expansion of solid. Let us cross multiply this. Gamma into V1 theta 2 minus theta 1 equal to V2 minus V1. We cross multiplied this here, or gamma into V1 theta 2 minus theta 1. We bring this minus V1 to the left hand side, becomes plus V1 equal to V2. Now let us take V1 common. V1 is taken common, so inside within the bracket remains gamma theta 2 minus theta 1 plus V1 is out, here remains 1 equal to V2. So the new volume of the solid for theta 2 minus theta 1 degree Celsius rise in temperature will be this much. Okay, where gamma is the coefficient of cubical expansion of the solid. I hope you understood this. Now we knew that alpha is the coefficient of linear expansion of solid and beta is the coefficient of superficial expansion of the solid, and gamma is the coefficient of cubical expansion of the solid. And these three are related. How are they related? They are related in this way: alpha equal to beta by 2 equal to gamma by 3. This is the relation among three coefficients of solid. Coefficient of linear expansion of solid is equal to coefficient of superficial expansion or surface expansion of solid by 2. It's equal to coefficient of cubical expansion or coefficient of volume expansion of solid upon 3. Okay, this is the relation among the three coefficients. I hope you understood. Thank you so much for watching this video. I hope you liked this video and understood the concept which I tried to teach you. Stay safe, stay healthy, and please don't forget to subscribe the channel and click on the bell icon to get notifications for more videos uploads like this. Thank you.